Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius Podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy of my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out. And I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids, on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition, or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on Current Initiatives. And now, to our guest.
Hello, this is Richard Jacobs with the Finding Genius podcast, now part of the Finding Genius Foundation. I have Dr. Terry Hrubec. She's a DVM, which I believe Doctor of Veterinary Medicine, also a PhD. She's a professor of anatomy and embryology at the Edward Via College of Osteopathic Medicine. And we're going to talk about the gestation process and birth defects that occur and her work. So Terry, thanks for coming.
Well, thanks for having me.
Yeah, tell me a bit about your background and then how you got to the position you're in now.
Okay, so I'm a veterinarian, as you mentioned, and I also did a PhD, so I'm on a research-focused track. And I've been doing research on birth defects and how to prevent them. And all of a sudden, the mice in my colony, in my control group, started to develop birth defects. And they hadn't had them for, 10, 15 years. So I tried to investigate what was actually causing those birth defects. And it turned out to be the disinfectant that they were using to clean the mouse room.
Oh, wow. That's really interesting. So they were just spraying this disinfectant, not on the mice directly, but even just the residues were causing birth defects.
Correct. So they use it to mop the floors and to wipe off the cages and things like that. And that was sufficient exposure to cause the birth defects in the mice.
What were the chemicals that were in the cleaners that you identified?
They're quaternary ammonia-based cleaners. So they have big, long chemical names. I'm going to give the abbreviation. So one is BAC, benzalkonium chloride. The other is DDAC, which is dimethyl diethyl ammonium chloride.
And these same cleaners are used in human applications, right?
Absolutely. And this is of particular concern because with the COVID epidemic, everybody's cleaning a lot more often. You see, people spraying everything down. There's all these hand sanitizers before you walk in the grocery. And a lot of those disinfectants and cleaners contain these quaternary ammonia compounds.
Yeah, I'm sure during the past 2 years, that everyone sprayed everything to death. It was horrible. And I'm kind of sensitive to that stuff. So I say, or just leave it dirty. I'd rather it that way. But I'm sure
Right.
that people around that 8 hours a day, has anyone done any environmental studies or working studies to see how much, the levels of these quaternary ammonia compounds?
Right. So there have been some studies that have looked at exposure pre-COVID and mid-COVID, and they have found both that levels in the home have increased because of COVID, and it's related to how often the participant in the survey, how often they would disinfect their home. So the more that they disinfected, the higher the levels were in the home. They were measuring the amount on the dust in the house. And then they also looked at blood levels. And again, the more a person reported disinfecting, the higher the levels they found in the blood.
Yeah, I imagine myself at a lunch counter or at a restaurant. They spray the tables, they wipe them down, all that stuff. You're sitting there and your arms are on the table, and your food's in the table. And I would think that an appreciable amount would get into people's food, especially if this cleaning was done 50 times a day in a restaurant, for instance.
Right. So it does, unless you rinse it off, it keeps building up on that table. Every time you put your hands down on the table, say to pick up your silverware or just to rest your hands on the table, you're going to be picking up some of that disinfectant. And then, if you eat and you touch your food with your fingers, say those French fries that you're, popping into your mouth. So you can get an exposure that way just from transferring it from the table into your food.
So in the mice, what was the birth defect level rate? Was it tremendously high or just a little bit?
So in the mouse strain that I'm working with, you almost never see the birth defect. It's like 1 in 5,000 mice might have it. We were seeing it up to about 20% per litter. So mice have multiple babies called pups, and they'll have anywhere from 2 to 20. And so I would see 20% of those babies would have this birth defect. So that's pretty high.
Yeah, that's incredibly high. What about the ones that didn't have the birth defect? And the ones that did you look at their motor skills or their temperaments, longitudinally, or was the birth defect so bad it killed them?
So this particular birth defect is responsible for what causes anencephaly or spina bifida in people. In the mice, we were more seeing the birth defect in the head region. That particular birth defect is not compatible with life. So in a human, the baby will die in late gestation or very shortly after being born. In the mouse, we found that they were dying in sort of mid-gestation. If they were born, this is going to sound a little disgusting, but the mother eats the baby because she doesn't want a dead or dying baby to be among the healthy babies. So that's just what they do naturally. And so you would never actually see one of these pups born that way, because as soon as it's delivered, the mother will eat it.
Yeah, that's pretty gruesome. So once you noticed this, how did you figure out that it was the chemicals being sprayed that caused this? And then what did you do about it?
So it took almost a year and a half to figure out what was causing it. And we tested maybe there's something in the food, something in the water, something in the bedding, anything that could possibly have changed. We looked for infectious causes, just a whole across the board trying to figure it out. And after about a year and a half, we sort of had it narrowed down to something that happened right in the mouse room and could then further localize it to the disinfectant. They had just started using a new disinfectant that contained these quaternary ammonia compounds. And it was a very sudden shift from no birth defects to all of a sudden, within 2 weeks, seeing the mice with the birth defects.
Crazy.
So then we tried to eliminate that exposure. And so we set up what we thought was a clean room in the mouse facility. And unfortunately, the mice in that room still had birth defects. And we think it was, now we know that quaternary ammonia disinfectant can adhere to dust particles. And so we think it was being transferred through the air handler system to create dust in our clean room. And that was enough to expose the mice. So we then moved him to a facility that doesn't use these quaternary ammonia disinfectants at all. And then we were able to get mice without the birth defect.
Well, what about you guys? I mean, once you saw these birth defects and everything, all the people that work in the lab, were they freaked out? Or were they just like, oh, we're fine?
It depended on the individual. So quaternary ammonia compounds have been around since the 1940s. So we're used to having them around. We're used to seeing them. And the EPA has conducted a risk assessment and came to the conclusion that they are not harmful. And so some people were not freaked out at all and others were. You can use what they call PPE, protective equipment, to try to limit exposure. And so they have those available when you're working with these chemicals.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
Did you switch to different cleaners, and what worked better?
So we did switch, and this new facility where they don't use the quaternary ammonia disinfectants, they use a bleach-based cleaner. And so in the facility with the bleach-based cleaner, we didn't see the defects. So that's how we eliminated them.
Okay. So what's the implication going forward for your research from observing this?
We're now trying to bring this to the human realm. You alluded to this a little bit ago. Is this a concern for people? Very little research has been conducted on the effects of this disinfectant exposure in people. Mine was the first study to actually measure levels in human blood. The risk assessment in some early studies indicated that even though people are exposed to these disinfectants, none of it is absorbed into the body to get into your blood and circulate to the other organs. By detecting it in the blood, we were able to show that, yes, they certainly are absorbed into the body and can affect other organs. So we would like to take this further and see, does this exposure lead to the problems that we've been seeing in mice? So we know it affects reproduction, causing infertility in both males and females. We know it causes birth defects in the babies. Other researchers have found that it affects mitochondrial function. Mitochondria are the powerhouses of the cell. They produce all of the energy. And so this disinfectant inhibits mitochondrial function, meaning you're not producing as much energy for that cell to do their basic job. And then other researchers have found that it affects cholesterol synthesis and metabolism. Now, we all think cholesterol is bad. We want to have our blood cholesterol levels low. And that's true, but cholesterol is a really important chemical. It makes up a lot of our cell membranes for every single cell in the body, and it helps cells communicate between each other. So it's vitally important. And by inhibiting the cholesterol synthesis, you make less cholesterol available to go into the membranes of these cells, and that totally affects their function. Okay, so we see a lot of critical effects of this disinfectant exposure.
Have you gone back over the EPA study? Were you able to get access to it? And did you find problems with the study, or you're just doing new studies to supplant the old?
The study, all the risk assessment studies are conducted under very rigid testing guidelines. They have to measure specific things. They have to dose at a particular concentration. Those studies use primarily weight gain and weight loss as their indicators of toxicity. So we're finding toxicity using much more subtle endpoints than weight gain or weight loss. In our studies, our mice are not losing weight. They show no signs of overt toxicity. They're, running around. They're happy, healthy looking mice. But if you look at development or reproduction or mitochondrial function or this cholesterol synthesis, then you start to see effects. And so I'm not faulting the risk assessments. They just don't measure more subtle endpoints.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
So, yeah, they were completely inadequate, it sounds like to me. So how are you studying these risks yourself? What does your experimental design look like?
So the test that we ran in people was sort of a pilot study first initially, is the disinfectant, are the residues there in the blood, And do we see changes similar to what we see in the mice and the cell culture experiments? So we measured inflammation, markers of inflammation. We measured mitochondrial function, and then we also measured cholesterol synthesis. This is in the blood of people who were in our study. And so we found...
Oh, so you had people in a study, but how were they exposed to these quats?
We didn't actually, you can't do experiments on people. So we just took random participants who wanted to enroll in the study. And so these are, just average people off the street. And they would enroll in our study, come in, we would collect the blood. And then we measured these different endpoints from that you could measure in the blood.
Yeah, but how do you know if these people were exposed a lot? Like, why not talk to a cleaning company and get some of their people, and then people that don't work for a cleaning company?
Right.
I don't know,
so
people that are teachers and compare it.
That's the experiment we would love to do. This, as I said, was a pilot study. It was our first initial one. We had no idea whether people would even have the disinfectant residues in their blood. We don't know where the exposure is coming from. So we can think that cleaners, restaurant workers, or the cashiers at the grocery store now with COVID, and they're spraying all these disinfectants. We could think that they might have the higher exposure, but we don't know for sure. So it's possible that all the disinfectants that are used in your home are actually giving you a higher exposure than your occupation might be giving you. And so until we can narrow that down a little bit, it's difficult to design a study where you have an exposed, what you expect as an exposed group and what you would expect as an unexposed group.
Well, I don't know. You get a baseline of people that, again, don't work in a cleaning place and people that do. You'd have to, I guess, maybe evaluate their homes, which would make it much harder. But if you get enough people, I think the average person, the average home, maybe that effect would be filtered out.
That's what this study would do. The one we would love to run. We would, again, collect information about their potential exposures. Are they exposed at home? Are they exposed in the workplace? We think maybe a gym where you go and work out might have high exposure because you're spraying down all the equipment. So we would have to ask questions like that to try to judge where the exposure is coming from. And then
if I were you, I would just go straight to nail salons or people that work at like Bed Bath & Beyond. They're like, you can smell all the horrible there's no way those people are not getting hit constantly.
And what's interesting is the same chemicals that are used in the disinfectants are added to all of those products that smell because it helps to disperse the smell better. It helps volatilize it so that you can actually smell it more.
No, that's great. So your study with the random group, are you done with it? What have you learned, if so?
So we saw that the changes that we saw in the mice are also present in the people. So we saw increased markers of inflammation. We saw the decreased mitochondrial function, and we saw altered cholesterol synthesis. So that indicates that this exposure that we can measure in people might be causing the same effects that we're seeing in mice. So we might be causing birth defects. We might be causing increased inflammation. Again, we just need another study to actually test that.
What's holding you back? Is it affording a larger study? Is it time, or when's this going to happen?
So for all big studies, you have to get grant funding. And we have not managed to get a granting agency interested in the study at this point.
How are you measuring what's going on with the people? Are you drawing their blood, or what does it look like? Let's say you get a group of, 100 hairdressers or nail techs to do this. What would you have to do to them to ascertain what's going on?
We would draw blood. It's a relatively small sample, about 3 tablespoons worth, 2 to 3 tablespoons of blood. And from that sample, we can detect everything that we've tested in our pilot study and couple that with a detailed questionnaire to try to assess where is their exposure coming from and what their actual exposure is.
What if you were able to piggyback on like a place that does, blood draws, like a big lab, like CPL Labs or something, and you were able to work with them and get data, not names or anything, but they ask people's profession. They're drawing the blood anyway for other reasons. Maybe you could piggyback and that might save your experimental cost. There'd be enough people coming into a blood draw center that also work in the places that they say they work in. That might work for you. I don't know.
That would work if we could also administer a detailed questionnaire.
Yeah, maybe you guys can partner with a place like that. And it might make it cheaper, just an idea.
Yeah, that's a good suggestion.
So what other hypotheses or theories are you working on testing?
So right now I have a study going on where I'm looking at what is causing the birth defects in the mouse pups that I'm seeing. I'm trying to figure out why they develop the birth defects. So we're looking at inflammation in the placenta, and we're also looking at inflammation in the mother. So both of those could be affecting the rate of the birth defects in the babies. So the placenta is really a unique organ because it's sort of at the interface of the mother and the baby. And so there's a lot of things that happen in the placenta that can affect the baby's growth.
What about the mother and the father mice themselves longitudinally? I mean, mice live, 2-3 years, maybe even a year. Can you look at them and see what their effects are long-term to being exposed to this stuff, not just the pups only?
So we've done some studies with that. What we've shown is that the effects on reproduction and the effects on the fetal development persist throughout life and even into the next generation. So if the mother or the father is exposed and you then stop that exposure and then breed the mice and look at the babies, they're still affected even though the parents were exposed pre-breeding, pre-pregnancy. And then
you said it adheres to dust particles. So did you have to move these mice to a completely different facility that you knew didn't have these compounds in the air?
Yes, that's how we designed the study. So we expose them. We then move them to the clean environment and then let them stay there for a different length of time and then breed them and look at the babies. And so we saw
have you characterized the changes? Is there like massive epigenetic changes, or is there actual DNA damage, or how would you guys characterize what's causing this problem?
It's epigenetic. There are studies that have shown that these disinfectants don't cause DNA damage. So the changes we're seeing, especially over multiple generations, that has to be epigenetic.
And when you moved mice to the new clean environment, did you wait varying amounts of times to start breeding them? Like, if you bred one right away versus waited a month to breed one, maybe the effect would then go away.
Right, it doesn't. So we did try that. Epigenetic changes occur in the egg and the sperm, and both of those are the stem cells that are going to produce the egg and the sperm are formed relatively early in gestation. Okay, so if you're exposing a mother, you're also exposing the stem cells in that baby that will become the egg and the sperm when that baby grows up. And so it's that single exposure of that mother during pregnancy that carries it on to the next generation.
Have you tried it where you expose just the father and or just the mother to see, and both?
Yes, both exposures, single sex exposures, both will cause the birth defects in the baby, which is really quite exciting. Well, unless you're the mother or father in question, but it is one of the first times that they've shown that a male exposure preconception is sufficient to cause a birth defect.
Yeah, that's crazy.
Yeah.
Again, have you looked at the levels of these compounds in the blood of the mice right after exposure, and then maybe a month of no exposure, 2 months of no exposure, 3, 4?
We've been able to detect it in the blood of the mice. We haven't done a longitudinal study looking at concentrations and how long they last. Other researchers have looked at blood levels after an exposure, and they drop pretty quickly. So we have been able to measure levels in tissues of the mice even months after exposure, and there are still levels in the tissue. Okay, but it disappears relatively quickly from the blood.
Well, where do you think it's being harbored if it lasts for a while? And the fat, where does it go?
We've tested the brain, the liver, and also the testes of male mice, and we can detect it in those tissues. It does not appear to concentrate in the fat.
Well, how do you think it has such persistence? I mean, the levels do drop quickly, so maybe that suggests that even a low concentration of this can cause birth defects if it's being quickly eliminated from the body, but maybe there's a long tail of it and a certain residual amount takes a long time to get out. I don't know.
Right. So again, this is all relatively new research and it's not very well characterized. So it's possible it remains in the body for long periods of time in these different tissues. For example, there's a number of other chemical toxicants that can stay in the body for years. PCB is a very well-known one, and it will stay in your tissues and then can cross over into the baby when the baby's born and also through the breast milk. But we just don't know about these disinfectant residues and where they stay and how they're transferred to the baby. Again, that would be a great study to conduct and, follow if your exposure is for 1 month to this low level, where does it end up and how long is it residual in those different tissues?
Yeah. Also, how is it excreted from the body? Is it breathed out, sweated out, pooped out, peed out? How does it leave the body?
Most of the evidence show that it's pooped out. So it actually gets in through, when it gets into the stomach, it's absorbed, okay, and it gets into the blood circulation. When your blood goes through the liver pulls it out and puts it into the bile. And when the bile enters the intestine to help you digest your fats, the disinfectant residue goes with it.
Do you notice any difference in the stools before and immediately after, and a day or two after, and then a month after exposure?
No, the mice appear completely normal.
But the stools, I mean, they look the same. Yeah. I don't know if you've sampled them.
Yeah, they look the same. I mean, if you feed a high enough dose, then it's going to be irritating, and you do see a difference. But we don't work anywhere near that high dose. We're down at very, very low doses.
So, what's your speculation on what's happening to people that are going to, an office every day, or, they just go to the store, they go to Starbucks, they go to 7-Eleven or whatever, but they're in regular contact with this stuff and for short periods of time versus the people that work at one of these places that are there all day and spraying and breathing and spraying and licking and,
Right.
What's your speculation on what's happening?
It is possible, but again, what I have is a mechanism. This is physically possible, biochemically possible, but it's not been proven to actually be the case. But I think there's a number of what we think of as chronic diseases whose main underlying defect is increased inflammation. So it's that increased inflammation that is contributing to that disease. And I think that this exposure is actually contributing to those chronic diseases that we think about. Now, those tests haven't been run, but you start with a hypothesis and then you have to test it. So, I would like to hypothesize that our chronic low-level exposure might be contributing to inflammatory diseases like obesity and diabetes and arthritis and all these other diseases that have an inflammatory component to them.
Okay.
But again, that needs to be tested.
Right. I understand you being careful. You're trying to be a good scientist. That's good. What do you think is going to be happening with your lab and your work over the next year or two?
Oh, I would love to do this one study that we've discussed where we're trying to correlate occupation and or other outside work exposures and correlate that with blood levels of the disinfectant and then try to get a handle on where the exposure is coming from. And then what might be some of the health effects of that exposure? Do we see increased inflammatory diseases? Do we see increased immune diseases and things like that? That's the direction I would like to go. At the same time, I'm a developmental biologist, so looking at how the birth defects are formed and what's actually causing them, that's where my passion is.
What do you think is the primary method of entry? Is it breathing this stuff in, or is it, touching residual surfaces and then it's going into your mouth?
Probably both, but I think inhaling is probably the greatest exposure. When you spray a compound, any hand sprayer makes this mist, and it's easy to breathe in those mist droplets. And also, since it adheres to dust, anytime you're in a place where you're breathing in dust, you're going to get an exposure that way. Another sort of interesting fact, I mentioned when you eat a compound, it then goes through your liver and some of it can be excreted. When you actually inhale a compound, it goes straight into your blood, so you can get a higher blood level that is moved around your body in the blood before it gets to the liver. So blood from your intestines goes to the liver first, and it can detoxify some of that disinfectant. Whereas when you inhale it, it runs through your whole body before it gets to the liver. So you end up with a higher exposure.
Yeah, I mean, why hasn't anyone then been dissecting the lungs of mice that are exposed? If it appears that the primary method is probably more inhaled than eaten, why don't you look at the pathology of the lungs and look for inflammation there and things like that, scarring?
They've done that, and what they find is that there's irritation and also some inflammatory changes. It's well known in people that, in mainly hospital workers, they will get an asthma. It's called occupational asthma and lung irritation from these cleaners, from these disinfectants. So that's been well documented. And that's until my work and others, that was the known effect that everybody says, okay, they're completely safe. Other than this fact, you can get occupational asthma and an irritation.
They're completely safe, except you have asthma from all the cleaners.
Right.
But I'm sure that causes no problem. Craziness. Well, very good, Terry. What's the best way for people to find out more? I don't know if you have a lab website page. How can they find out more about your experiments?
I have the school, the Edward Weil College of Osteopathic Medicine, has a webpage for me, and it outlines some of my research and publications.
Okay. And that's the best way to reach you?
Yes, it is.
Very good. Well, Terry, thanks for the good work you're doing and for coming on the podcast. I appreciate it.
Right. Well, thanks for having me.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.